All right, guys, so today we're going over 2.5, which is postulates and paragraph proofs. We're going to identify and use postulates about points, lines, and planes, and write a paragraph proof. So some vocab for you. Postulate, a statement that describes a fundamental relationship between the basic terms of geometry. Postulates are accepted as true without proof. An axiom is a statement that is accepted as true. Proof is a logical argument in which each statement you make is supported by a statement that is accepted as true. Theorem is a statement or conjecture that can be proven true by undefined terms, definitions, and postulates. A deductive argument is a proof formed by a group of algebraic steps used to solve a problem. And then a paragraph proof is an informal proof written in the form of a paragraph that explains why a conjecture or a given situation is true. And an informal proof is just a paragraph proof. So some postulates for us here. 2.1 is through any 2 points, there's exactly one line. So right here, we've got a line N is the only line through points P and R. 2.2, that through any 3 non-collinear points, there's exactly one plane. So we have 3 non-collinear points on a plane. 2.3 is a line contains at least 2 points. So line N contains points P, Q, and R. A plane contains at least 3 non-collinear points. So plane K contains non-collinear points L, B, C, and E. 2.5 is if 2 points lie in a plane, then the entire line containing those points lies in that plane. So A and B lie in plane K, and line M will have to contains points A and B, so line M has to be in plane K as well. And then up here, 2.6 is if 2 lines intersect, then their intersection is exactly 1 point. So lines S and T intersect at point P. And if 2 planes intersect, then their intersection is a line. So planes F and G intersect in line W. Little study tip, recall that points, lines, and planes are undefined terms. The postulates that you have learned in this lesson describe special relationships between them. So right here, our first one, explain how the picture illustrates that each statement is true, then state the postulate that can be used to show each statement is true. So we have points A, B, and C, and determine a plane. So we have a point A, point B, and point C, if you can see that on my paper. And so that's saying that it's on a plane. Those are 3 points. So it's gonna be 2.2, oh, you can see that, 2.2, so this one right here, talking about the 3 points on a plane. So it'll be postulate 2.2. And now planes P and Q intersect in line M. So we've got plane P is this guy and plane Q. And then we've got line M going down the middle here. All right, so now we know we're talking about intersecting. So we're gonna be talking about one of these two. And since we're talking about planes, it's gonna be postulate 2.7. Just like that. Let's go ahead and flip our pages here. All right, so determine whether each statement is always, sometimes, or never true, and then explain our reasoning. 2 intersecting lines determine a plane. This will always be true because between any 2 points, or intersecting lines, there are always at least 3 non-collinear points, and that is in postulate 2.2. And then 3 lines intersect in 2 points. Well, that's never going to be true, because in order for 3 lines to intersect at 2 points, 2 of those lines would have to be the same. All right, so one method of proving statements and conjectures is a paragraph proof, and it involves writing a paragraph to explain why a conjecture or a given situation is true. Paragraph proofs are also called informal proofs, although the term informal is not meant to imply that this form of proof is any less valid than any other type of proof. So our steps. Step 1, list the given information, and if possible, draw a diagram to illustrate this information. Step 2, state the theorem or conjecture to be proven. Step 3, create a deductive argument by forming a logical chain of statements linking the given to what you are trying to prove. Step 4 is justify each statement with a reason. Reasons include definitions, algebraic properties, postulates, and theorems, so the things that we just went over. And then step 5, state what it is that you have proven. And then we have our midpoint theorem is another one. So if M is the midpoint of AB, then AM is congruent to MB. And here's an example for you. Given that M is the midpoint of XY, write a paragraph proof to show that XM is congruent to MY. So given M is the midpoint of XY, because they tell us that, and we're proving that XM is congruent to MY. So those are two given informations to us. And here's a picture to show that. So step 3 and 4, our argument, is if M is the midpoint of XY, then from the definition of the midpoint segment, we know that XM equals MY. This means that XM and MY have the same measure. By the definition of congruency, if two mesh segments have the same measure, then they are congruent. So then finally, therefore, XM is going to be congruent to MY. So we're going to write a paragraph proof for number 3. Given that C is between A and B, AC is congruent to CB, write a paragraph proof to show that C is the midpoint of AB. So if C is between A and B, so we're going to start off with what they gave us, then by definition of between A, B, and C are collinear, so they're on the same line. And since that's true, AC plus CB would equal AB. So if segment AC is congruent to segment CB, we're trying to use that because again we're trying to use the midpoint. So then, by definition of congruency, they have the same measure. I can spell measure. So this means that AC will equal CB. So from the definition of a midpoint, of a segment, if C is between A and B and AC is equal to CB, then C is the midpoint of segment AB. Whew. So that's all of that one. So number 4, proof point Y is the midpoint of XZ, Z is the midpoint of XY, and prove that XY is congruent to ZW. So we are given that Y is the midpoint of XZ, and Z is the midpoint of YW. So by definition of a midpoint, XY is congruent to YZ, and YZ is congruent to ZW. Using the definition of congruent segments, XY will be equal to YZ, and YZ will be equal to ZW. So then I can also say XY is going to be equal to ZW by the transitive property. And thus, let me see here, segment XY will be congruent to ZW by the definition of congruent segments. And that's our first taste of proofs. Email me if you have any questions.